Well, good morning, everybody. Today we are starting a brand new topic, and it's going to be 10-1 Analyzing Data Display. This will be a very easy or just a conceptual lessons with minimal amount of math, right? Less calculations. But before that, let's talk about the review. So from a long time ago, you learned from middle school or before that to find the median of a data set. So back in the day, you learned something called mean, median, mode. But then, in this lesson, we just need to find out what is median. Just to review, how do you find the median of a data set? So median is just the number right in the middle of a data set. So in example 1, I see that there are 7 numbers. Let's say these are the ages of, let's say, 7 children in a family. 2 years old, 4 years old, 7 years old, 9, 11, 12, and 12. And if I were to find the median age of these 7 children, all we have to do is to look for the middle number. Now, if there's a lot of numbers in the data set, it will be best to actually cross out one number on the left and one number on the right to kind of just find your way in the middle. So I see that there's a 2, there's a 12, right? You kind of just label them instead of crossing it out. And then, that's one number on the left, one number on the right, and one number on the left, one number on the right, and you see that the middle number is 9. So that means the answer is that when you want to find the median of these numbers in a data set, it's going to be 9. That means the middle child's age is 9 years old. Very easy, isn't it? Now, in example 2 will be a little bit different. I see that, well, instead of 7 childs, we have 7 children. We have 8 children here, and their age is like, 2 of them are 1 year old, they're 3 years old, 4 years old, so on and so forth. Well, first of all, this list is not in order from least to greatest. So the first step is to put them from least to greatest. So I'm going to just mark it. So this is, that's 1, that's another 1, and then there's a 2 here, right? Then I see there's a 3, then I see there's a 4, and after 4 I see there's a 6, and then there's an 8, and then finally there is a 9. Well, we're going to do the same strategies. To find a middle number, we're going to cross one number on the left out and cross one number out on the right. So that's gone, right? So these are the pair of numbers on the left and on the right. Let's do another pair. Let's do another pair, and I see that this time there are 2 middle numbers. Well, in the case of having 2 numbers in the middle, you're going to find the average. So that means to find the average, you add them and divide it by 2. So the 3 plus 4 divided by 2, which is 3 plus 4 is 7. And when you cut 7 in half, it's 3.5, okay? So that means your final answer, the median of these 8 numbers is going to be 3.5 or 3.5, and then that's it. So today you will be using median as part of your data analysis in lesson 10-1. In today's lessons 10-1 Analyzing Data Displays, we're going to cover 3 different types of displays, and they're going to look different and provide you different types of data. Let's take a look. The first type of display is called dot plot. So let's say these are the ages of each child ranging from 8 to 15 years old. I see there's 1 child that is 8 years old, 2 children that are 9 years old, and then so on and so forth. So using a dot plot, we could see that, well, first of all, I know the age of every individual child, and I know that how many childs did I sample, because if you add the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I see that I asked 13 children for their age. And I could see that, well, which is the most common age, and it's going to be 11 years old. And the age that are not common will be the 13 years old, 14 years old, and 15 years old. And I see that most children are around 8 to 12 years old because it cluster around there. So from here, you're able to see that, hey, I know that the age of every individual child, as well as, well, which age is the most common and the least common. Well, for histogram, it's a little bit different. Well, in histogram, I will only see a range of numbers. For example, in this histogram, it looks like a bar graph, but it is not. The bars are touching each other. And here, I could still see how many people I sample. I see that there are 2 people make 6 to 7 posts per day. And I see that there are 3 people make 8 to 9 posts per day. And here I see that there are 5 people make 10 to 11 posts per day. And I see that the 3 people make 12 to 13 posts a day. So if I were to find out, well, how many people did I sample? Let me see. I add 2 plus 3 plus 5 plus 3. So which is going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means I asked 13 people about how many posts they made per day on their social media or whatever, right? Usually posts is about social media. But here's the thing, I would not know how many posts does each individual make exactly, because here I'm showing just a range of number. I only know 2 people that make 6 to 7 posts, but did they make 6 posts? Did they make 7 posts? I don't know. Likewise, there are 5 people that make 10 to 11 posts per day, but did they make 10 or 11 posts? I don't know. So we call this a group data, because we don't know the detail of each individual. So therefore, we cannot tell exactly how many posts each person make per day, but we could only tell the range of the posts each individual make per day. Lastly, there's a box plot. Well, here in this example, box plot looks like this, where you should have 5 important numbers, right? One number on the left, and then on the left of the box, in the middle of the box, and then on the right of the box, and then at the right of the tail. So there are 5 important numbers to make a box plot. Now in a box plot, let's say in this example, if I were to find out how much money does each person carry in the wallet, I see that the least amount of money one person carries, it's a little bit less than $50. But exactly how much, I don't know. And I see that there's one person that carries way more than $100 right here. Again, how much does he carry? I don't know. And then I see that, well, there's somebody that carry $100 and maybe around 90 bucks and around 70 bucks. So in the box plots, I do not know how many individual I ask. I don't know if I were to ask 50 people or 100 people. I have no idea. All I know, it's just some characteristics of the data sets. I know what's the least amount of money in a wallet. I know what's the largest amount of money in a wallet. And I know what's the median. This is called median. Let's put it right here. This is the median. That means, that means the middle person in the data set will carry around 90 something dollars, right? And I see that, and this one is called a first quartile, right? This number is called first quartile, and that's that's a U right there, ARTILE, and then this is called third quartile. Okay, we're just gonna write these words down. And the median sometimes is called the second quartile. Okay, now why are they called quartiles? It's because in a box plot, each of the segments represents a quarter of a data. That means, what does that mean? It means that 25% of the people that I ask have anywhere between maybe less than $50 to around $70 in the wallet. And then 25% of the people I ask have anywhere between $70 to $90 in the wallet. And then 25% of the people I ask have anywhere between $90 to $100 in their wallet. And then lastly, the last 25% of the people that I ask has anywhere between $100 to maybe $105 in their wallet. So each segment represents 25% of the data. So this is 25%, and this is 25%, and then this is 25%, and then lastly, this is also 25%. So as you could see that, well, the median really separate the bottom 50% and the top 50%. And because it's right in the middle, median by default means it's right in the middle. And you could see that, well, the middle 50%, right, the middle 50% has anywhere between $70 to $100 in their wallets. Let's take a look at the first example. In this example, it says Manuel plans to buy a new car with the gas mileage shown. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he researched? Well, here, the car that he wants to buy has 26 miles per gallon. That means each gallon he could drive 26 miles. And here are some mileage of the other cars, and we want to find out whether, he's getting a good deal with this car that he's buying in terms of the gas mileage. Well, to do that, since we want to preserve the individual data, we're going to make a dot plot. So you're going to make a dot plot. I see that the smallest number is 25. The highest number is 45 right here. And once you gather the dots, you generate this dot plot here. Now, in this particular lesson, you do not have to create a dot plot by yourself, but I'm just telling you how do you create, how does a dot plot form, but you don't have to create it. Well, here I see that, there is a car with only 25 miles per gallon, and there's a car with 45 miles per gallon. And I see that around, the average cluster around maybe 25 to 31, and then 35 and 45 are kind of the outlier. Well, so here it says, the dot plot shows that most of the values are clustered between 25 to 28. Well, so how does it compare to the car that he wants to buy? Well, it seems like 26 is within 25 and 28, so the car that he wants to buy kind of is comparable. It's almost the same as the fuel efficiency of the other cars out there. And also, if you see that there are dots that is placed very far away from the cluster, we call this the outlier. Right? Outlier are the unusual data sets, data numbers that you found in the data sets. They're there, but it's just that they're so high or so low to a point that they're not clustered with the other numbers in the center. In example 2, we have a histogram here. Let's take a look at the problem. It says the data shows the age of a random sample of 30 viewers of the show. Based on the findings, should the market team launch the campaign to 24 to 34 years old during this particular show? So there are 30 people and this is their age. And I see that the smallest age, it's around the teens, which is maybe about like 15, 16 years old. Maybe even less if I could find another number. Oh, I see there's a 14 years old, right? So about 14 years old. That's the youngest person. Well, the oldest person, it's probably around the 30s. I see there's a 32 years old. Oh, I see there's a 37 here. So we have people ranging from 14 years old to 37 years old. Again, you don't have to learn how do you create the histogram, but this is a histogram that represents everybody, the 30 people here. And from the histogram, I see that most people, because of the height of the bar, I see that most people are between 15 to 19 years old and 20 to 24 years old. Not so much on the teens and not so much on the people who are almost 40 years old. So let's go back to the question. It says, should the market team launch the campaign to 24 to 34 years old? Let's take a look at the people between 24 to 34 years old. Since it says 24, I'm at the edge of this bar right here. So instead of a look at 25 to 34 years old, there's only 4 people that is between 25 to 29 years old. And there's only like 3 people that is between 30 to 34 years old. Well, out of the 30 people, we don't have a lot of people around 25 to 34 years old or 24 to 34 years old. So should the market team launch the campaign to this particular age group? The answer is no, because they only represent a very, very small age group compared to the rest, because most people are between 15 to 24 years old. So to answer that question, we're going to say no, because this, 7 people is not even half of 30, which is right here, the number of people that we asked. Well, finally, in example 3, we do have another data set. It says students at a local high school organize a fundraiser for charity. Caitlin, the Students' Council president, announces that more than half of the students raised over $50 each. The amount of money raised by a random sample of 24 students is shown. Do the data support Caitlin's claim? So remember, Caitlin claims that more than half of the students raised over $50 each. Now, since we talk about half, remember a box plots separate the data sets into quarters and 50%. So to answer that question, it will be best to use a box plot. So here are the 24 students, and to create a box plot, again, which you don't have to create it on your homework, you're going to order them from least to greatest. You're going to find the smallest number, which is 25, the highest number, which is 68, But the middle number, which there's two of them, so you take their average, so 45 plus 45 divided by 2, which is 45 as well. So let me show work here. So how do I get this? It's 45 plus 45 divided by 2, and that's why you still get 45. And to find the quartiles, right, since this is the middle, you separate it in half like this. You cut the data sets in half. And then from here, so this is like a half of the data sets, you find the middle. And I see that there are two numbers right in the middle. So between 32 and 32, the first quartile is 32. So again, you add the two numbers divided by 2 to get 32. Likewise here, right, for the third quartile, you add the two numbers, 50 plus 54 divided by 2, and you get 52. So that's how you find these 5 numbers, 25, 32, 45, 52, and 68, to create a box plot. And let's take a look at the box plots here at the bottom. So since you found those 5 numbers, you're going to create a number line with the minimum of 25 on the left and the maximum of 68 on the right. And then the median is the middle of the box. The first quartile is on the left of the box, and then the third quartile is on the right of the box. So let's take a look at Caitlin's questions. Remember what Caitlin says is that she wants to claim whether more than half of the students raised over $50. Now, $50 is right here, right? This is $50, okay? But I see that half of the people, this is half, right? Remember, this is 50% right here. This is 50%. I see that half of the people raised actually $45 or more, okay? Not $50 or more, $45 or more. So that means that less than half of the people raised $50 or more. So to answer her questions, it says, the box plot shows that based on the sample, the median amount of salary collected was $45. Since half of this population collected $45 or less, the data do not support Caitlin's claim. Remember, she claimed that more than half of the people raised over $50 each. I'm like, this is not true. This is actually less than half of the people raised $50 or more. Well, finally, on the last example, example 4, we're going to determine what kind of display should we use for certain type of questions. Well, in this example, it says Helena's dance team scored 68 points at a competition. The scores for all the teams that compete are showing. So these are 16 people, and these are their scores at a competition. Helena wants to know what place her team finished. Should Helena use a dot plot, histogram, or box plot to display the data? Now, since she wants to know what place her team finished, first place, second place, third place, fourth place, that means she wants to keep the data of each individual. So since I want to keep all the data, right, I would not want histogram, because histogram would group the data. Remember, histogram is something that do not display the data of each individual set, so we would not want this. A box plot does not show any characteristics of each individual because it only shows you 5 numbers, the least, the greatest, and the quartiles. It does not tell you the detail of each individual, so we would not use that. So the only plots, the only displays that's actually still keep the individual's information would be a dot plot. Therefore, we should be using a dot plot to display the data. Well, your homework will be very similar to these examples. It will assess you on how to obtain information from different displays, box plot, dot plot, and histogram, and as well as which display you should use for certain situations. So that's the end of the lesson, and the next couple minutes will remind you how to get to your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page, and you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. Click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks. So if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step, step by step, step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that it's not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.